Hello, my name is Parth Borker from the Bergen County Academies in Hackensack, New Jersey. I'll be presenting my project, The Tumor Suppressing Capabilities of Naturally Occurring Compounds, a Mechanistic Approach. This was done under the mentorship of Dr. Robert Pergolesi. Breast cancer is very prevalent in the United States, as you can see in these first two statistics. To combat this, I chose three naturally occurring chemicals, indole-3-carbinol, or I3C, Apigenin, and sulforaphane. These were chosen because they work by different mechanisms of action, and thus it was theorized that they could work in a synergistic manner. Due to these different mechanisms, the hypothesis of the study is that these compounds, in combination, will exhibit greater anti-carcinogenic effects than each compound alone on breast cancer. In terms of the research objectives, this study was conducted in two phases. Phase 1 was a dose-ranging study to determine the optimal concentration of each compound, and has been completed. Phase 2 consisted of analyzing the combinatorial effect of the binary combinations, as well as analyzing the mechanism of action for the most effective combination. I'll now move on to the materials and equipment for both phases. Here's a summary of different pathways by which each chemical works. What clearly stands out in these graphs is the variety of different pathways exhibited by each chemical, which ties back to the hypothesis and my reasoning for picking these specific compounds. In the field, breast cancer presents in two main types, the ER-positive tumors and the HER2-positive tumors, which interact differently with drugs due to different surface receptors. To make this study more applicable to a bigger variety of patients, I decided to use the MCF7 cell line to represent ER-positive tumors and the SKBR3HR cell line to represent HER2-positive tumors. Also listed here are the compounds which I used in this study and the equipment used in this study. The first assay that was used was the cell proliferation assay. This is a calorimetric method to determine the number of living cells over time. As a result, the lower the absorbance, the lower the cell viability, and thus the higher the anti-carcinogenic effect. The next assay that was used was a cell cycle analysis assay. This is a fluorescence-based assay that measures DNA content, and using this is able to measure the amount of cells in each cell cycle stage. For instance, cells in the S phase will have more DNA than cells in the G1 phase, and thus they will take up proportionally more dye and will fluoresce more brightly. As a result, the machine is able to categorize each cell into whichever cell cycle stage it is based on the fluorescence. And the desired effect of this assay is to induce G1 arrest, so the more cells in G1, the better. I'll now move on to the first phase of this study. Here's my methodology behind this experiment, and as you can see here, you can see the two different controls tested, the concentration range, how the data is presented, and that a student's t-test was used to evaluate significance. Each assay was run in triplicate, and the data is presented as an average of standard deviation. This is the data that was collected from the first experiment. As you can see here, on all of the y-axes are the cell proliferation numbers, and on the x-axis is the different treatment. The blue lines represent the highest concentration, the orange lines represent the medium concentration, and the gray lines represent the low concentration. Figures 1 and 2 represent the two time points, the 24 hours and the 48-hour time point in the MCF cell line, while figures 3 and 4 represent these two time points in the SKBR3HR cell line. In regards to the MCF cell line, there was a clear trend for sulforaphane and Apigenin that the concentration is negatively correlated with cell proliferation. And for I3C, the highest concentration clearly had the greatest effect on cell proliferation. This is true at both time points, and these effects were also mirrored in the SKBR3HR cell line, as you can see in figures 3 and 4. There is also a clear effect of time in both cell lines in all compounds. Based on these results, I decided that the optimal concentrations for phase 2 were as follows. Sulforaphane would be at 100 micromolar, Apigenin was 100 micromolar, and I3C was 250 micromolar. I'll now move on to phase 2, which evaluated the combinatorial effects of these chemicals. And here's the methodology behind these experiments. You can see here that there are two different controls being tested, the concentration range, the different combinations tested, how the data is presented, and that a student's t-test was used to evaluate significance. And each assay was run in triplicate, and data was presented as an average of plus or minus standard deviation. Figure 5A is shown here, and it shows the treatment of MCF7 cells at the 18-hour time point. On the y-axis is cell proliferation, and on the x-axis are the different treatments. In order to increase accuracy, I decided to test the 3 chemicals individually again, as well as the combinations. Unfortunately, the S plus A and A plus I combinations were contaminated. However, this will be followed up in future experiments, as will be noted later. In terms of the data itself, there is a clear effect of the S plus I combination on cell proliferation compared to the control and to both sulforaphane and I3C individually, as the combination decreased cell growth by 66% compared to the control. Figure 5b shows the treatment of MCF7 cells at the 24-hour time point. As with Figure A, the cell proliferation is on the y-axis and the treatments are on the x-axis. Unfortunately, the S plus A and A plus I combinations were also contaminated, but similar to the previous time point, there's a very clear effect on cell proliferation by the S plus I combination, as it decreased the cell growth by 81%, however, compared to the control. However, compared to the 18-hour time point, the difference between the compounds originally and the combination was less pronounced. Here's a summarized analysis of both of the previous 2 graphs. It is clear that across both data points, the combination of S plus I was very effective compared to the controls and the compounds individually. I will now move on to the next experiment of phase 2, the cell cycle analysis. And as mentioned before, the desired effect is to have a higher G0/G1 phase value. And this first graph shows a treatment on the MCF7 cells at the 24 hours time point. On the y-axis, we have treatment this time, and on the x-axis, we have cell cycle distribution by percent. There's a clear trend from the graph that the compounds individually do increase G0/G1 arrest. However, in terms of the combinations, the S plus I combination was extremely effective in G0/G1 arrest, as 30% more cells were in G0/G1 arrest compared to the control. This is also high compared to the compounds individually, as sulforaphane had a 26% in G1, had 26% more in G1, and I3C only had 20.6% compared to the control. Results at the 48-hour time point were very similar to the results at the 24-hour time point. As you can see, while the trend is less pronounced, most treatments did still induce G0/G1 arrest. And again, the combination of sulforaphane plus I3C was the most effective in doing so. Now I'll move on to figures 6b and 7b. 6b represents the 24-hour time point, and 7b represents the 48-hour time point. On the y-axis is the relative amount of cells, and on the x-axis is a different fluorescence. As you can see here, the area under the graph would represent the amount of cells that are located at that fluorescence. As you can see here, in both figures in the top left, the control has many cells in the S phase and many cells in the G2/M phase. Compared to these controls, the compounds individually, the sulforaphane, which is in the top right of both, and the I3C, which is in the bottom left of both, these do decrease the amount in the S phase and do increase the amount in the G1 phase. However, if you take a look at the bottom right graph in each figure, you can see that the sulforaphane plus I3C has an even more pronounced effect, as the amount of cells in the S phase are drastically inhibited and the amount of cells in the G1 phase are drastically increased. And here's a summary of the data for the cell cycle analysis, and the most important fact to note is that these results suggest that the combination of S plus I produced the most pronounced genotoxic effects on cells, as it induced G0/G1 arrest, preventing the cells from progressing into mitosis. Now for a conclusion of both phases. In phase 1, I determined that the anti-proliferative effects properties for all 3 chemicals were present across all 3 time points and cell lines, and that the highest dose tested for each compound was the most effective. As a result, I used this highest dose for phase 2. In phase 2, I determined that the combination of sulforaphane and I3C demonstrated the most significant synergistic effect against cell proliferation and in G0/G1 cell cycle arrest. I have various future plans to continue this research study. The first is to further evaluate the I3C plus sulforaphane combination to determine its mechanism of action. This will be done using a Western blot assay and using an HDAC activity assay. The next is to evaluate the tertiary combination of all 3 chemicals using the cell proliferation and cell cycle analysis assays. The final will be to conduct the studies in phase 2 in the SKBR3 HR breast cancer cell line in order to have a greater impact on the field. Taking the time out of your day to listen to this presentation, my name is Parth Borker from the Bergen County Academies in Hackensack, New Jersey.